Welcome to True Projects. In this video, we are going to explain about the project which is towards improving breast cancer classification using an adaptive voting ensemble learning algorithm. Before getting into the execution, first let's understand what's the project. So we all of us heard the term called breast cancer, right? We all know it is very serious issue and also that has to be detected in the early stages. So breast cancer, it affects large number of women worldwide and diagnosing it early, it plays a key role in improving outcomes. However, just using one single classification model isn't always sufficient because in real world medical data is complicated with many overlapping patterns and noise. So traditional classifiers sometimes struggle with these complexities resulting in less accurate predictions. So it is very important to to use an advanced machine learning techniques such as ensemble-based models to improve the diagnostic accuracy. So to tackle all these issues, in this project, we are proposing a model called Ensemble approach. The proposed system uses an ensemble approach that incorporates several machine learning models to classify breast cancer. So here we are using voting-based ensemble classifier. So this classifier brings together with the four different machine learning models, which are extract classifier, light gradient boosting, image classifier, and linear discriminant analysis. So in the voting classifier, all these four algorithms have been combined. This is named as ELR-LE. So this combined named ELR-LE has demonstrated the impressive performance. Additionally, it assesses how well this ensemble model performs compared to the individual classifiers and the other leading models. So our main aim of the project is to identify the ensemble model is working better detecting and diagnosing breast cancer. So the idea is to improve the classification of tumors, whether they are malignant or benign. So by combining multiple machine learning algorithms, this combined approach aims to achieve a higher level of accuracy than individual models, ensuring more reliable and precise predictions. Moving on, the proposed system uses an ensemble approach. So to further improve the performance, we are integrating the other ensemble model that is called stacking classifier. Here, the stacking classifier also combines multiple models, but in the stacking classifier, we are combining decision tree, random forest, and light GBM. This new approach will result in even higher accuracy compared to the initial voting classifier model. Additionally, we have built the front end using Flask framework. So we have used Flask framework to build the front end by user testing, including user authentication features. So this enhancement is aimed at improving the overall usability and accessibility of the system. So moving on, how did we implement this project? So first, we have imported the necessary packages which are required to the project's execution. Then we have loaded the breast cancer dataset and explored the dataset. Once we explode, now we move on to processing, that is data processing. So this data processing, it includes removing any duplicate entries, performing data cleaning, etc. After that, we select the relevant features. So then we select the relevant features. And then we do label encoding to prepare the data for analysis. Then we split the data into training and test sets. Training is for training the models. Testing is for evaluating the models. So here we have trained adaptive voting classifier and stacking classifier along with the other machine learning models. And among both the models, stacking classifier has performed well. So with this model, we have built the front end using Flask framework. So in the front end, we have used stacking classifier to make the predictions. Moving on to the algorithms used, we have used rich classifier, LDA, extra tree classifier, light GBM, LDA, and adaptive voting classifier, extension stacking classifier. So this is the proposed model and this is the extension model. So extension model has performed well, so we have used it for deploying it in the front. This is all about the theoretical concept. Execute, we need some basic requirements, which are software and hardware. So coming to software, we need Anaconda. Primary language is Python. Front end is Flask. Backend framework is Jupyter Notebook. Database is SQLite 3. Front end technologies are HTML, CSS, JavaScript, and Bootstrap 4. And coming to hardware requirements used, we have used operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Now let's execute the project. Execute, we need to open the code folder which contains project source code files. So let's open the project source code files. These are the project source code files. Let's understand each of them. How will they be used in the project? So coming to the first archive folder, in this folder, we have the dataset. That is a breast cancer dataset. So this is the dataset that is used in this project. So here we have many features. So from these features, we'll be selecting the important features. So the last column we have is dimension worst. So this dataset will be using to predict the disease. That is whether the person has breast cancer or not. This is the target variable and all these are the independent variables using which we'll be predicting the breast cancer. Now let's close this. Get back. So this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the project style. And coming to the templates folder, this folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python, handles server-side operations, such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in HTML templates. And this is the model file, which contains the algorithm information. This will be loaded into the project code during runtime. This is the notebook.ipynb file. This is the Jupyter notebook file, which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in the individual cells, which makes it popular choice for the data science. And the last file is a database file, which is useful for storing the user information. And this is the sample file in which we have the test cases to predict the front end. So let's open it. So we'll be using all the test cases to predict the breast cancer in the front end. So these are the inputs that we'll be giving and the application will be predicting the diagnosis. So now let's close this. Now let us execute. To execute, we need to copy the path of the code folder from the address bar of the file explorer. So copy the path. Now let's open the Anaconda prompt. Here, using the command cd followed by the space, is the copied path and then click on enter. Here, current directory is changed to the code folder's path. Now we have to compile the app.py file. So give the command python space app.py. Now click on enter. This command, it will execute the Python script and perform a runtime check for any syntax errors or logical issues. After adding the app.py file, Fast Framework will host the application at the local default address, which is the local host and the port. Now we have to copy this local link provided by the Flask framework and paste it into any web browser. So I'm copying the link. I prefer Google Chrome. So I'll use the Google Chrome. Paste the link here at the end or end. So this is the web page of the project, which is developed using Flask framework. So now we have to click on sign up. So click on sign up. If we are registering newly, we have to fill in all these details. I have already signed up, so I'll directly sign in. So click on sign in, give the username and the password, and click on login. So we have logged in successfully and we are redirected to the prediction page of the project. So here you can see the parameters, right? We need to enter all these parameters as the input. Based on the given input, we'll be getting the prediction. So first, let's understand what are these parameters and then enter the inputs. So here the first parameter which we have is radius mean. It is the average distance from the center to the perimeter of the tumor, indicating its size. The next one we have is texture mean. It is the average texture of the tumor surface, reflecting variations in the pixel intensities and smoothness. Coming to perimeter mean, it is the average length of the boundary surrounding the tumor, which helps assess its size and shape. Coming to area mean, it is the average surface area of the tumor, providing insights into the overall dimensions. Smoothness mean, it is the average measure of how smooth or rough the tumor surface is, indicating its irregularities. Concavity mean, it is the average degree of indentation in the tumor's contour, which can suggest malignancy. Next one we have is concave points mean. It is the average number of points where the tumor surface is indented related to its shape. Last one we have is symmetry mean. So coming to the symmetry mean, it is the average level of symmetry in the tumor shape with asymmetry potentiality indicating abnormal growth. So this is all about parameters. Now let's give the input to all those parameters. I already told you that we have a sample file. So let's open and give the test cases from that. So these are the test cases. Let's select the first test case and execute the project. So I'm copying the radius mean, get back to the application. Now let's give the texture mean, copy it, paste it, perimeter mean, copy. Next one is area mean. This we have not copied. Smoothness mean is 0.099. Concavity mean, concave concave point means, paste it. Symmetry mean. And here what we have prediction is 0, which means that person has no breast cancer. So now let's click on predict and see whether the person has breast cancer or not. So here we got the prediction as predicted with the benign breast cancer. Benign, it means that you have tumor cells, but it doesn't cause any effect. It will not even spread. That means no breast cancer. Now let's give other set of inputs. So click on prediction again. Let's use the second test case. Copy the radius mean, texture mean, perimeter mean, area mean, smoothness mean, concavity mean, concavity points mean, symmetry mean. Click on predict. Before that, let's see what does that we have. 1, which means that person has breast cancer. Now click on predict. So if you observe, application has correctly predicted that malignant breast cancer, which means that person has the breast cancer and that tissues will spread and it will lead to serious concern. So it is better if we take precautions immediately. So now let's give some other inputs. So let's use this sixth input, sixth test case. So click on prediction, copy the radius mean, texture mean, perimeter mean, area mean, smoothness mean, concavity mean, concave points mean, symmetry mean. Now click on predict. So here we got the prediction as predicted with the benign breast cancer. Let's see what is the diagnosis. So here if you observe, both have been correctly matched. That means that the application is correctly predicting the breast cancer using the stacking classifier algorithm. Now click on graph to see all the graphs of the project. So this is the accuracy graph. Accuracy is the error metric that is used to evaluate all these models. So here on x-axis we have accuracy score and on y-axis we have algorithm names. Among all the algorithms evaluated, we can observe that stacking classifier is having the highest accuracy. So this is the precision score graph. So similar to accuracy, here also on x-axis we have precision score and on y-axis we have the algorithm names. Similarly, we have recall, FN score, specificity, and sensitivity. All these are error metrics. So now click on sign up. This way, by using the ensemble models and training it with the breast cancer data set, we will be able to predict the breast cancer in the early stages itself and prevent the disease without affecting the person. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.